Lesson 5-1 on polynomials and Lesson 5-2 on degrees of polynomials. So first off, let's go through some vocabulary. A monomial is just an expression that is a number, a variable, or a product of numbers and or variables. But these have to have variables that have exponents. If they have exponents, they can't be negative exponents. Now, if it's just a constant or if it's just a number, constant is just a monomial containing just one number. So if I just said 4, that is a monomial, but we would consider that a constant. There is no variables involved. Next is polynomials, which is a monomial or a sum or difference of two or more monomials. Now, monomial or polynomials do have specific names. Monomial, we've just gone through, is one term. So it's one group of numbers and or letters. A binomial is two terms. So that's two groups of numbers and or letters separated by plus or minus signs. So if I said some examples, so a monomial could be like 4a. A binomial could be 4a minus 1. A trinomial has three terms. So that could be 4a squared minus 2a plus 1. That would be three terms because I have three groups of numbers and or letters. So first we want to just be able to identify if the following expressions are monomials and then explain why. So R is a monomial, and this one R is just one group of numbers and or letters. Next one, Wx, yes, that is a monomial. I'm not dividing by a variable, so that is important. If you see any division of variables, that's a clear red flag that it's not a monomial. This next one, -5 divided by t. No, this is not a monomial because I'm dividing by t. And remember, a monomial can be a product of a number and a letter, not a quotient. 3.125, yes, this is a monomial. We would consider that a constant because it's just a number. Next, -12, x to the 5th, y to the 3rd. Yes, that is a monomial. It is one group of numbers and letters, and it's a product of numbers and letters. Next, 4 divided by n to the 4th. No, because if I were to put n to the top as a product, it'd be 4 times n to the -4th. And we already gone through that if you have a negative exponent, it cannot be considered a monomial. MNOP, yes, that is a monomial because it's just a product of one group of letters. 2ab to the -2nd. No, this is not because of the negative exponent. -3.2, yes, that is a monomial. It's just a number. Next one, 8c squared f minus 5c. No, that is not a monomial because I have two groups of numbers and or letters. That would be considered a polynomial. Next one, -2 over v cubed. No, that is not a monomial because I'm dividing. There's a quotient with a variable. This next one is yes. And the reason why this one is yes is because I don't have negative exponents. There's a variable's not in the denominator. I have a fraction, so I have a number multiplied by a variable. So keep that in mind. As long as it's just a number in the denominator, it's fine. Next, we want to classify each expression as a monomial, which means one term, binomial, two terms, trinomial, three terms, or it's not a polynomial. So x squared minus 49, this would be a binomial because there's two groups of terms, or two groups of numbers and or letters. Now, one way to determine that is if you count the number of plus and minus signs in there, it's always one more than the number you counted. So I count 1. 1 plus 1 is 2. 2, that means I have two terms, which is a binomial. Next, the square root of 3 times mn plus n cubed. This would be a binomial. Next, negative xy to the 6th z. That's just one term, so that's a monomial. X plus 1 over x plus 1. This is not a polynomial because I'm dividing one of the terms I'm dividing, so it can't be a polynomial. Next, 1/2 b plus 1/3 b squared plus 1/4 b cubed. This is a trinomial. It has 3 groups. 19. This is a monomial. This next one is not a polynomial because it's division by a variable. Next would be a 1, 2, 3, so this is a trinomial. And the reason why this is a trinomial because I have groups of constants and variables, so numbers and variables, they're all products of it. Next, we want to write each expression as a polynomial in simplest form and then name the polynomial. So here I have 2x to the 5th minus 2x to the 5th is, I don't have any x to the 5ths. All I have left is a 7x minus 3, so that's 2 terms. So this is a binomial. Next, if I distribute, that's going to give us a negative 3a squared plus 21a squared b plus 6ab. I can't combine anything, but I have 3 terms, so this would be a trinomial. Next, if I distribute, that's going to be a negative p to the 4th minus p to the 3rd plus p to the 3rd plus p to the 4th, which means if I combine everything, I end up with 0. So this would be a monomial. Next, I have 1/2 x squared minus 5x squared. So if I get 6x squared, so if I get common denominators, 3 minus 5 is negative 2. Negative 2, 6 is negative 1/3 x squared. The x cubes cancel out, so I just have one term left over, so this is a monomial. Next part is dealing with the degree of the polynomials. So first, a degree of a monomial is just the sum of the exponents of its variables. So if I have one group of numbers and or letters, I just add up the exponents in that group. And that would be the degree of that monomial. But if you have a degree of a polynomial, you would find the degree of each term, so each monomial, and then the degree of the whole thing would be the greatest degree of each of the monomials. And the degree, so if you have a constant, those have a degree of 0. Linear functions, a degree of 1. Quadratic has a degree of 2. Cubic has a degree of 3. Now there are more, so a degree of 4 would be quartic, and the degree of 5 would be quintic. But right now for this video, we're just going through 0 degree to 3 degrees. And then the last part is standard form of polynomials. Here you can write them in descending order, which means the terms decrease in degree from left to right. Other times you might write it in ascending order, which means the terms are increasing in degree from left to right. So our first example, we want to write the polynomial in standard form and give its degree. So this one would be negative y to the 3rd plus y. That's in standard form, and the degree would be 3. Because this term has 3, this has 1. 3 is bigger than 1, so a degree of 3. This next one would be 4x to the 7th plus x to the 5th minus 2x squared plus x. This would have a degree of 7 because 7 is the biggest exponent I have in each of the terms. Next, I would have 8y to the 7th minus 4y to the 2nd. Actually, it would be plus y cubed, and then minus 4y squared. That would be in standard form, and this would have a degree of 7. Next, I would have negative 2x to the 11th plus 2x to the 9th minus 1x squared plus 9. This would have a degree of 11 because that's the biggest exponent. Next, we want to write the terms that describe the degree and the number of terms for each polynomial. So this one has a degree of 3, and the number of terms, this would be trinomials. So the degree of 3 would be cubic. So this would be a cubic trinomial. This next one has a degree of 2, and a degree of 2 is quadratic. Let me rewrite that. That means if you were to graph it, it would be parabola shape. This is a quadratic binomial because there are 2 terms. And this third one, this has a degree of 2. So this would be a quadratic. And it's only 1 term, so this would be a monomial. And this last one has a degree of 1. So this is a linear. And it has 2 terms, so linear binomial. And our last ones, we want to evaluate each polynomial. So they're telling us what to put in for x. So if I put 0.3 in for x, and I'm going to use my calculator very quickly on this one. So we have negative and then parentheses 0.3 end parentheses, and we're going to raise that to the 5th power minus parentheses, and it's important that you put this in parentheses, 0.3 end parentheses, and we are cubing that, so raise that to the 3rd power minus 11 times 0.3 plus 2, and that gives us an answer of negative 1.32943. Now if we put negative 0.2 in there, so we have a negative, and then parentheses negative 0.2, raise that to the 5th power, minus parentheses negative 0.2, raise that to the 3rd power, minus 11 times a negative 0.2 plus 2 gives us an answer of 4.20832. And the next one just putting 2's in there. So 2 times 2 cubed. 2 cubed is 8. So 8 times 2 is 16 plus 4 squared, 4 plus, or 4 times 2 squared, which is 16, minus 2 plus 2. So 16 plus 16 is 32. Negative 2 plus 2 is 0. 32 plus 0 is 32. So this one will be 32. If you put negative 5 in there, 2 times negative 125. So 2 times a negative 125 gives us a negative 250, plus 4 times 25, which is 100. That would give us negative 150 minus, and this was negative 5, so minus negative 5 plus 2 gives us negative 143. So that's our lesson on polynomials and the degrees of polynomials.